Hey, welcome back to Math with Patrick. It's April 14th, and we're solving problem number 114 from this Daily Epsilon calendar today. All right, how many triangles are there with integer side lengths and a perimeter of 23? So, okay, I think we both know what a triangle is. Integer just means whole number. Technically, it could also mean like 0 or negative numbers, but it would be really weird to have a triangle with negative distances for side lengths. So that's just not going to work. And then the perimeter has to be 23. So like this is way too small of a triangle because the perimeter is only 9. One more thing that we should be cautious about when forming triangles is we shouldn't have some side length that's too long. So for example, and I can exaggerate here, if I have like a 100 for my longest length and then like a 10 and a 5, well, there's like no way that I'm going to be able to create a triangle with these lengths. The two shorter ones must add up to more than the long one. So even if I did like 50 and 50, that's still going to be too short because sure, these sides could touch, but I'm only going to be able to create like a straight line out of 50, 50, and 100. And so finally, if I like tick one of them up to 51, then I have just enough wiggle room to create an actual triangle. Another thing that we're doing today is basically a counting problem. We're just counting how many triangles work. And like usually for counting problems, just like kind of starting at the start, you should count methodically or like have some kind of like system in place, some kind of plan. Because I could just start in the middle, right? I could say like, I don't know, 7, 7, and then 9. Cool. This is a triangle because the two small ones add up to more than the big one. And then 7 plus 9 is 23. But like, I don't know where to go from here. And I want to be able to kind of start on one end and go to the other and know that I haven't missed anything. To me, it would make the most sense to either start at the triangle that has either the side lengths that are closest in value or start at the triangle who has side lengths like most disparate or far away in value. I think I'll start with the first idea. So 779 was honestly really close, and maybe that'll be one of my first, not the first, but one of my first triangles in my list. I know that 8 plus 8 plus 8 is 24. And so 7, 8, 8 will get to 23. And this is a triangle because, the two smaller ones do add up to more than the big one. When all my digits or all my side lengths are close in value, I'm not really worried about that condition. It's more so when I'm like at the bottom of this list that I'll start worrying about the two of these lengths adding up to be more than the third one. So let's see, how can I change these values around? I'm pretty sure if I say something like 8, 8, 7, that's just going to be the same thing as the original triangle. And I'm trying to keep the values as close as possible. And so I guess, yeah, maybe 779 makes the most sense to me next, just because that kind of like changes these values, but the smallest one still stays the same. And I guess that's what I'm going to do. Because like there's no way that this could have been an 8. Because again, like 8, 8, 8 would have been 24. That's too big. So I think I'm going to try to keep my smallest number on the left side. And if I try keeping the 7 the same and then tick this one down and this one up again, then all of a sudden my smallest number is actually 6. So I think this is how I'll count methodically. I'll just keep this as the smallest length of my triangle, and then I'll see how many different ways I can count with 7s and then 6s and then 5, 4, 3, 2, and hopefully 1 as well. Okay, so what did I do here? I ticked the 7 down by 1. This one could go up by 1, and this 9 can stay the same. Okay, so there's another one. And let's see. I guess if I go up even more with the 8, this one has to go down, so I just kind of copied what was over there. Then maybe I could go down again with the 7 and up again with the 9. Okay. And then maybe I could go down again with this and then up again with that. Okay. So I'm starting to notice a little bit of a pattern here where, so I have 7, 6, and so 5s are going to be here. And it looks like there is a way to count these where these decrease. And so that's going to be my next like system that I have in place to just make sure that I'm counting everything right. So if I tick this one down to a 5, let me make this a touch bigger. So 9 and then 9. So that still adds up to 23. And then, well, this could be a 10. I guess, hold on. 11, 10, 9, 8, 7, 6. Ooh, okay. I'm like rethinking how I'm going to count these. Maybe I'll have these be as close in value as possible, and I'll count down here and count up going this way. Okay, I think that's my plan. So now that I have that idea in place, if I count down here, we'll go 8, 10, then 5, 7, 11, right? And then 5, 6, 12. And then here, I caught myself. This isn't a triangle because 5 plus 6 is only 11 and 12 is too big. And so here, I'll keep this on the page just so I can like have that reminder that this one actually doesn't count. Okay, so looks like I've done all that I can with 7s, 6s, and 5s. So let's try 4s now. The most like even I can get my numbers would be 9 and 10. And then let's do that same thing where I'm ticking one down, ticking the other one up, and then stopping once it no longer makes sense, once I can no longer create a triangle out of it. So 4 plus 8 is 12, bigger than 11, that's fine. But then I think this one is where it's going to break, where, yeah, 4 plus 11 again, 4 plus 7 is 11 again, and 12 happens to be too big. And now I'm realizing why this 12 keeps on showing up, because 12 is more than half of 23. So if I split it into 3 numbers and 12 is my biggest one, well, then these have to share 11, and that's just too little. So anytime that I see a 12 show up in this right column, I know I've gone too far. Okay, I think I can kind of speed up my process now. 3, 10, 10. 3, 9, 11, and then that adds up to 12. And then the next one would have been too small. And then we can go 2, 10, 11, 2, 9, 12. Oh, actually, yep, there it is. Shouldn't have done that one. And then I think I have one more, right? I have 1, 11, 11. So if my system worked, I should have 14 triangles. Let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There we go. And because I counted in this like systematic way, I am very sure that I found all 14 and I didn't miss any, and I didn't accidentally count things that are not triangles. So there's my solution. Maybe you have a different way of doing this. I think you could even solve it like with a 3D graph where you say like these are your 3 variables x, y, and z for the third dimension. Though I figured if I'm counting up 14 objects, might as well just count them up one by one. All right. Thanks for working on this with me. I'll see you tomorrow.